although Dr. Shamshad has already started, because of some, like, there was a huge traffic congestion that led to delay in starting the session. So we apologize for the same. So now, coming to the another part of this statistical analysis technique, which is known as the principal component analysis. And since day one, we have been talking about the reflective scale and the causal formative or the formative scale. We also have seen the difference between these two type of construct. And again, to reiterate, whenever you plan to use existing scale or develop your new scale, the first important thing is to identify which type of construct it is, type of latent construct. So this principal component analysis, why do we need this? And in what case we can put this principal component analysis, or we can utilize this analytical technique of principal component analysis. Another name of this is also a data reduction or a dimension reduction technique. Like we discussed yesterday with EFA, that is also a dimension reduction. Why we call it as a dimension reduction? Because we start initially like number of item is equal to number of latent factor. And then we see the variance explained, and then we choose the number of factor which can explain the maximum variance in the item. So that's how we decide. So similar concept is there in the principal component analysis also, but how this is different from the exploratory and the confirmatory factor, that we'll see. So why do we need this principal component analysis? So imagine in this case, just see this data set. So what can you see here? That these are the participants. These are the 13 participants, and these are the intake of those participants. Like this is the intake of fruits, this is the intake of vegetable. And in this article which we have shared, they have used a food frequency questionnaire where they have categorized the intake like in less than a week or twice in a week or less than, once in a month or something like that, depending on the food frequency questionnaire. And these are the food items. So that was also like, it has been converted into a Likert scale of 0 to 5 or 0 to 4. And since if I have collected this dietary data using a food frequency questionnaire, and I have responses for these multiple food items like this. So now I want to summarize my data to identify patterns of dietary behavior. Why I want to summarize the data to identify the pattern? Because I want to reduce the dimension. In this case, I'll have to, if I don't reduce it, and if I have taken 24 or 25 items, the summarization or the conveying my finding will be difficult for the reader. So that if I summarize that finding, it will be easy. And now again, how it is different from the free listing and pile sorting. In free listing and pile sorting, that's a qualitative technique where the use of these statistical technique like regression generally or correlation, that is not used. But in this case, it is more robust. Why it is more robust? Because here the statistical analysis or the statistical concept, you can check it mathematically. So that's how it is different from those two techniques. I think yesterday Bhavna asked this question, how this was different. So now if I want to summarize the data to identify the dietary pattern behavior, what will I do? And in this case, you will see if I consider these as a separate items like fruits, vegetables, food grain, dairy, and sugary drink. What is the difference between these items and the items which you have seen in the empathy? What is the difference? Can you see any difference between if I take these as a questionnaire and if I ask like yesterday, like if I see someone in pain, I also become sad. If I see someone in happiness, I also become happy. How this is different from how these items are different from the items of the Toronto Empathy Questionnaire, for example. Yes, so Dr. Ravi is writing formative, attitude and objects. Yes, and one more thing, like these are very distinct. if you see, classically, these are very distinct items. The items are, it may or may not be related. It may be related, it may not be related. But there is no, we cannot say that yes, there will be correlation between these items. Some amount of correlation, of course, since they are, eating eatable, so there might be some amount of correlation. But they are distinct with each other. Like if someone is eating vegetable, it is not necessary that he will take sugary drinks. Or if someone is taking vegetarian food, it is not necessary that he will take non-veg, or he will, he will be taking dairy. So each item is very distinct from each other. So that's the difference from the reflective scale which we have seen. So questionnaire, if I see, if I have to analyze that or to have summarized that particular dietary pattern, how I can simplify the data. So I just want to simplify my all those items by keeping the initial information which I took. I don't want a huge loss in my information, because why what can happen if I want to summarize or I want to reduce the dimension. Simultaneously, I don't want that my data or my information should not be compromised. So I want to preserve as much information as possible. That's why I want to use a statistical technique where these information can be preserved. So I can group these into some meaningful cluster, like maybe healthy eating versus unhealthy eating. So in this case, would exploratory factor analysis be a good choice here? Why and why not? And since I had started the discussion regarding the distinctness or regarding the relatedness of the items, so you can probably now you can understand this, whether it is a yes or whether it is a no. So if my question is, would EFA be a good choice
No,
here?
no.
No. Dr. Ravi is right. Dr. Anusha is also writing no. Why? Because they are very distinct from each other, and the classical difference between these two constructs is like the items correlatedness. Like if they are correlated, because you see all those statistical technique which we learned yesterday, the covariance, the correlation, the loading, if you see in the background, and again, like HTMT, the heterotrait, monotrait, the composite reliability, average variance explain, everything, all the analysis depends on the correlation, which is R. In the background it is happening, although it's not needed that you should know all those things. You should know the cutoff value, you should know how to interpret a finding whenever it comes. That's the only important thing for we as a medical profession, because we cannot understand each and every mathematical concept, but if we can interpret it in context of our data, then this whole purpose of learning these statistical methods or biostatistical method is sufficient. So EFA, you are very right that EFA is not a good choice here. Why? Because they are very distinct from each other. They may be related. Again, I'm saying you cannot say in the analysis that if the correlation coefficient between, let's say, if someone is liking dairy, he might like non-veg food also. There can be chance. But if you see such construct is not there since beginning. Such dietary pattern like healthy eating or unhealthy eating, that is not there in our brain. Means it is inserted means like through some mass media or some people or some behavior change communication, we have been listening to these words, and that has gone inside our head. Like you have seen, we have talked on the exploratory yesterday regarding how a child perceives the information whenever we see something. So these constructs are like we generally we classify these construct by taking some exogenous variable, which you have seen in this case. So that's why we cannot perform a EFA in this case. But still, I want to reduce the data. Why? Because I cannot present my data in 14 items, and I cannot say like I am taking all those ingredients or not taking it. So limitation again. What is the limitation of EFA in this scenario? So basically, the EFA is designed to uncover the latent construct, and that should be there since beginning, like which should be unabsorbable, like empathy or like anxiety. And EFA, it works well when we have understood the concept of shared. So remember that communality and uniqueness. So in case of a EFA, there will always be communality, which is a shared variance, means a common factor or a common latent construct affecting all the items. And the direction will be from the construct to the item. Whereas in this case, EFA is not expected to work well because it is not driven by a common underlying factor. But in this case, our again goal is not to find any latent construct, but my goal is to reduce the dimension of my dietary pattern, which is the observable grouping. So, because this again, I said that these diet variables like fruits or vegetables or sugary drink may not reflect a shared latent factor. So the key problem in this case is that EFA assumes that variance can be, if you can recall that diagram where we talked about if the variance is 1, then we define like if like 70%, if the value of the common variance means the value of commonality is 70, then we can say that 70% variance in the item can be explained by the latent factor. And rest 30% is the error, which is unexplained variance, which we also call as uniqueness. So we partition that variance, partition that one variance, let's say if it is 1, into 2 parts, a shared variance and an unexplained variance. That's why, we see that error term is there at each item, because each item we have understood that it may not be explained only by that particular construct. There can be some other latent factor also which can explain that particular variation in the item. But in case of this PCA, or in this case when my aim is only to reduce the dimension, I don't want to see any shared variance. So in that case, I'm interested in explaining the total variance rather than separating component into the shared and unique. So we have seen this measurement terms of job satisfaction, like these are the items, then they are the separate error. That is a type of reflective model. This is a type of, yes, this is a type of reflective model. And we have, in this case, this is again a type of reflective model, which we have seen like measurement error is at the item level. And this error is like, there is some shared variance, which we have seen. So this variance is due to the principal factor, again, the latent factor. And this variance, every item, like if I am talking about Y, then one variance can be broken into variance due to this principal component and unexplained variance, which is the error. So this is, here the measurement is at this level, measurement of error is at the item level. And items are highly correlated. And we have seen that the relationship between the item and factor in a reflective construct is like this item will be, this is the loading, which we have seen yesterday, this lambda, this is the loading. What we have been seeing in the two cases, which is the confirmatory factor analysis and the exploratory factor analysis. Now, if my item is like this, which is my, you can see this is again, this was one equation which we have drafted for one item, like I feel comfortable in my workplace. This item variance can be explained by this job satisfaction and by this error, this job satisfaction and by this error. So the variance in this is again partitioned into a variance due to this construct and the unexplained or the error term. So this was regarding EFA. Now coming to this, this was regarding the reflective construct. But again, this question was asked on day 1. Like I think Ashwati asked this, like why there is an error term here at the level of construct? Why the error term is not there at the level of each income, each item here? So here the kind of mathematical equation which we use for making this principal component analysis, since this is, we have understood that this is your dependent variable. So here, although I just don't want to use that term again, linear regression, because then people will be confused. Many of you know already. but it is like explained on the basis of equation. Forget about linear equation, where we know that y is equal to, you can say like y is equal to a plus a, where a is the one constant, and plus bx. So this is one equation, and on the taking this equation into account, this principal component analysis, or this, you can say this formative scale, we explain the formative scale, where each, and then you can write like this, b1 x1, and then you can write b2 x2, where b2 is another coefficient, x2 is another variable. So here you don't form this score, or the variation in this score is explained by all the factors like income, like wealth, like employment, like education. So the whole together, this makes the socioeconomic scale. And that's why the error is at the level of zeta. Why? Because if you can remember the equation there, the equation, we call it as a E towards the end. There is one error at the end. So this zeta, we are interested into total variance. Total variance means variance together by all these variables, not partitioned. We are not interested, since the kind of technique which we are using, it doesn't partition the variance into a variance due to this and due to this item separately. It works on the principle of total variance, not the partitioning of variance. So if it is working on total variance, it will take total this thing into account, and then there will be an error. And this, how do we explain this error? So this error can be due to, there can be some other, because all these item may not explain 100% variation in socioeconomic status. No scale, however accurate you are, whether it is a formative or it is a constructive, through any item, you cannot measure a true score, whether it is a reflective or a formative. Again, you remember we discussed an example of weight. Like if I take my weight with a sensitive, very sensitive scale, and in a span of, let's say, 1 or 2 hours, I take 20 measurement, even then you see that all the measurement will be different from each other if you increase the decimal, like if you don't take the whole number. And then how will I find my true weight? There is no way I can find my true weight. Means there will always be some amount of error, and that error is here. It again, if I see the total variance means variation in this socioeconomic scale due to all these variables. So I cannot explain 100% variation of this socioeconomic status by these
Ma'am,
variables.
sorry to interrupt you, ma'am.
Yeah,
I
yeah,
have a
yeah.
small query, ma'am. Income would be fixed, educational attainment would be fixed for a person.
Yes.
So where is the question of variance occurring at when you're measuring this, ma'am? Whether you measure the income in dollars or rupees or euros, it remains the same only.
Okay. It may remain same for one person, but it will vary from person to person. First is this,
It's same.
because variance we talk about in the population. Okay. One is this. Second is, yes, that's why I said now that we don't measure the error at the individual item level. I am not again, I'm not talking about measurement level here right now, but error will be there because socio-economic status is a construct which I have drafted. So there can be some other item which may explain this socio-economic status. Let's say, probably I have not taken, let's say, take a variable like social status. Here it is written social network. Let's say belongingness to some high social class. Okay. Or belongingness to some, let's say, this kind of social structure, politics. If I see, like if a family of me is related to any politician and belong to a politician, or if I am at a very high level, means a high level post, which you can say like employment status is like general thing, but I may create another thing, whether I am at a director level or admin, very high authority admin level or not. And if I take that also as one of the indicator, then maybe that will also add to some of the variation. So here the error is not due to this. Again, that's why I said wealth, employment, it will be fixed. But there can be some another variable. Let's say it can be some y variable which which will also add to the variance in the socioeconomic status. It is not only these 6 variables which will determine this socioeconomic status. So there
So,
will be
ma'am,
a
so
term.
according to you, ma'am, the construct, I mean, at this level itself, the factors what we are considering, there could be more number of factors responsible for SES. That's
Yes,
what you wanted to say.
yes, 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 yes.
So,
There
so,
can
so,
be,
so, 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 so basically, the SES, like Kupu Swami, if you're considering, so
yes,
that would have its inherent flaws because of, say, missing out on one particular factor which is not considered. This is what
yes,
you want to convey.
yes.
Okay, thank you.
Anything like Human Development Index or poverty or Kuppuswamy or any scale, whatever you have constructed to measure a construct, like whether it is a reflective or a formative, it is not going to represent the 100% variation. There will be, why? Because the way it has been designed. Way it has been designed means how will you test this? You will
So
test this on.
in that case, a systematic error, a bias would exist in SES.
Yes, and you can see it in everyday, like we have been seeing this. There are
Hmm.
various flaws of these scales. Like in one
Okay.
family, if we use like Kuppuswamy, and the same family, if we use Uday Parikh, we use
Hmm.
Mahajan and Gupta, you will find
Hmm.
that they all three
Difference,
are
yes,
giving some
yes.
other change in the scale. Someone is
Correct.
saying middle, someone is saying upper middle, someone is saying.
Hmm.
So we
Hmm.
wanted to do a study. We suggested one of our PGs that they can do like just discrepancy of these three. On single person you will find different amount of error using these 3 scales. So
Hmm.
yes, there is an error, you are very right. In any indicator, if you if you see it, there will be error, and this is due to there can be some other item. This is not due to some other factor, right? Some other item which might also explain this socioeconomic status, the variation in this socioeconomic status. We don't know about that. Who knows? Like these days, the scenario is changing every day. These days you might take like person who is very popular on social media, popular on, let's say, YouTube. See, that can, because things are changing now. Maybe for young people these days, if you ask from kids, they are not very much worried about, Uday Parikh, it became like a obsolete. If the person has television or not, bicycle has not. These days, it is not any, I mean, it doesn't hold true, like having a bicycle. But when it was drafted, obviously those things were important. So with changing scenario, now the socioeconomic status, social status, everything is changing. Social network, if you apply this scale to a person who is a 65-year-old, and if you applied this to a probably a teenage, so maybe the social network might differ. What I mean to say that with changing social structure, there will be appearance of new indicator, and the old indicator which we have chosen, they might turn out not to be that useful, which was drafted at the time of developing the scale, because these scales are dynamic, things are changing, people are changing, mindset is changing, society is changing, everything is changing. So you need to, that's why I said that even if any scale is there, you need to see how it is performing and how people are perceiving. Because ultimately, with any scale, what you are going to measure, you are going to measure something on human being. And if we are changing every day, maybe that is very subtle, but maybe after 10 years or 15 years, things will be different. It will may not be the same. So that's why some amount of error will always be there. Yes, any other standard? Dr. Manju, we are also clueless what is a standard socioeconomic scale, because that's a very hot topic here in our PG seminar and everything. We are still working on it. Let's see. Like people say use NFHS, but again they have used wealth index, and then they took a lot of other variables. I mean, I cannot answer this standard socioeconomic scale. Still, we are figuring it out, Dr. Manju. I'm so sorry. And then I think, yes, any other query before we move ahead? Okay. If not, so this was like, this we call it as a composite latent. Again, the term composite is here because you are constructing these scales. This composite, if you see the composite word, this is a composite latent variable where the error is at the level of Ashwati, and I think I might have forgotten the name of the person who asked this question on day one. Is it clear now why the error level is there at the factor in case of a formative scale, and at the level of item in case of a this reflective model? Is it clear now?
Yes, ma'am, it's clear.
Okay. And Shivam, I think I made one mistake yesterday. Probably if you are attending today, I will correct that after I'm done with this PCA. So I need to make a correction regarding what I said yesterday
Okay.
regarding that reverse scaling. So I was reading one book, and the point which you raised, that I got a good answer on that. So I'll tell you, if I forget, please remind me. So this is like a formative model. We know that.
Yes. Okay. Sure,
And
ma'am. Sure, ma'am.
here the measurement error is at the construct level. We know that. And all these items may or may not be highly correlated with each other. So the example in the paper which we have shared, that is the fruits and vegetable, it may cluster together in a healthy, in a healthy eating pattern. But this is again, like I said, that this is a composite indicator. This is not a latent construct. But I want to reduce my dimension and interpret the data in fewer dimension. So this is a practical alternative, the principal component analysis. So the people who were asking in the beginning what kind of analysis they can do if the scale is a formative for the dimension reduction. So probably Dr. Shibapriya or Dr. Renuka or Dr. Ansi, I can't recall, like, but someone said regarding their scale, like that's a formative scale. So if it's a formative scale, for the dimension reduction, you can definitely use this principal component analysis. The commands and components are very much similar to the exploratory factor analysis, except that shared variance. It works on total variance, so it doesn't partition that. So that's why we'll see. And that's why you will see in many paper, what people they do, we have seen, although I think we could not show it to you, that even if the scale is a formative, sorry, if scale is a reflective, people go for PCA. Why they go for PCA? Because in PCA, if you apply PCA, although that should not be the method of choice, the explained variance is very good with PCA because it doesn't partition. So if you see in a EFA, if it is explaining your 40% of variance, those item in PCA, it will explain 60-65%. So just to increase the explanation, like percentage of that variation, you will find that many time people, they, instead of principal axis factoring, which we have seen yesterday, that should be the method of choice, and oblimin as a rotation method should be choice in health and social sciences. But you will see that people go for PCA. We have seen a quite lot of article, and we were confused also, like why they have used PCA if they should have used either EFA or they should have gone directly for CFA. But I said that the same data, if you use EFA and if you use PCA, in PCA the percentage of variance explained will be much more than EFA. So that's why, probably because to increase that variance, because ultimately then what the reader will say or the reviewer will say, that your scale is not a good one. Why? Because like yesterday we have seen, if it is explaining only 30%, then rest unexplained. If it is 70%, the scale is not good. So just to get exemption from that less percentage of variance, if you apply PCA, you will get a good variance. But that should not be done, because that's not a method of choice. So what PCA does? So PCA basically reduces the dimensionality of the data while preserving, which is our goal. Like in the beginning, I said that I don't want to lose my information. So I want to preserve this as much as possible. So it creates new variables, and these are, in this case, it is not known as factor. Like in exploratory factor and all, we are always using the term factor for the latent construct. Here we'll use the term principal component, PC. So it creates a new variable which is called as a principal component, And that are the linear combinations of the original variable. Linear combinations means like the way I have just discussed, this one, where I was telling you the one equation is like y is equal to one constant plus, if there are three variable, so b1 x1, sorry, this is b1 x1 plus b2 x2 plus b3 x3, b2 x2, so on. I don't know how I am writing. And then there will be an error also. So it is a linear combination. This equation, we call it as a linear combination. Okay. So this is a linear combination of original variable. And the PCA, the technique, it takes this into account. And these components, they explain the maximum variance in the data set. So if I have to summarize how I'll do that, there is a EFA and PCA. So goal of this EFA is to identify latent construct, which works on the shared variance, whereas this PCA, my goal is to summarize the data, means reduce the dimension. So it works on total variance. Here, this EFA, the variance considered is common variance only. Total means it partitioned. Here, it doesn't partition. And interpretation is like they are the theoretical construct. Here, in case of PCA, they are just the component which represents the pattern. And when I have to, identify some hidden latent trait, then I'll use this EFA. When I'm just simplifying my observable variable, I'll use the PCA. So why PCA for these dietary pattern data? Because this dietary pattern, I have to summarize these multiple food variables into a few principal component that represents broader dietary pattern. And I have to use these components for further analysis, like for correlating dietary pattern with some other health outcome, if this is my goal. So now let's see how to do this PCA on the data set. So I'll first show the articles. Let me see. Mitra, no? This one was the article. No, Malla, though, I think I'll discuss.
Okay.
Could you read the article, this one which we shared? Malla.
Yes, ma'am. Yes, ma'am.
Okay, okay. So we'll discuss this once again. Like maybe I may ask from you guys, like to read and to explain how you now how confident you are in doing such analysis. So probably we may also design some scale on a Likert scale of 1 to 5 regarding your confidence and reduction in anxiety probably in dealing with these statistical technique. So yeah, coming to the Mitran. So this is the dietary, this was the article, dietary pattern of pregnant women and their association with the diet quality measure. So what they have done, if you see, I'll come down. This was the introduction section. So it was just an observation. If you see the study design, it was just an observational study, and they took a convenience sample of 251 pregnant women, which were hospitalized before delivery, and then in a particular hospital, and then they have just calculated the sample size.
Ma'am, sorry, ma'am, I'm digressing from the main topic, ma'am. We have taken a convenience sample. Is this the right methodology over here? Of course, this is not part of this particular discussion, but just
Generally, actually, in hospital setup, because they have done it in one pregnancy, this thing, obstetric and gynecological hospital. So there are two things, sample size and sampling. So sample size they have calculated, but sampling, why they have written convenience? Because the probability sampling, how will you use it is very difficult. You don't have a sampling frame. Frame in the sense it's not fixed. Every day, like people are coming. So in case of a hospital setup.
But then, ma'am, you would have had a hospital registry of so many people listed with you who are going to be coming, or who are listed. Perhaps they could have drawn a sampling frame from that.
But depends. Like in this case, in our setup also, if you ask if I want to do such
Ma'am, in our setup, we can't assume only, ma'am, because people come at the, at this,
yeah.
they are already dilated and then they are entering. So I'm not talking about we cannot,
I don't know about this area Lassi is in, which may probably like generally in US and UK, like you see, they don't do. European country, they don't use, but I don't know in which country this is. If this is from some African country or country which is very much similar to us, probably there's a maybe. Again, depends on the feasibility. Probably because of that, they have done it. And then you see data collection, they have done it. So coming to this adequate nutrition intake, okay, dietary pattern construction. So if you see, they have again taken this fruit frequency questionnaire. I'll show you the question also. And if you see the dietary pattern construction. So using a principal, if you see this, using a principal component analysis. Just a sec. So you can see they have written using principal. Yeah, someone can read this probably, I think. Yes, anyone? Any volunteer?
Using a principal component analysis, we assess dietary patterns within the 13 food groups. The suitability of factor analysis was determined with the KMO test and the Bartlett's test. A KMO value exceeding 0.5 is considered acceptable. We only considered components meeting an eigenvalue about 1.3. Factor loadings above 0.25 are considered significant. In our analysis, the KMO value was 0.562. We identified three components accounting for nearly 40% of the overall variance, that is vegetarian, modern, and prudent. The vegetarian pattern was marked by a substantial intake of cereals, cereal products, fats and oils, nuts and seeds. At the same time, the modern pattern was defined by a significant intake of potatoes, fats, oils, soft drinks, meat products, sugar, preserves, and snacks. Finally, the prudent pattern was marked by an important consumption of vegetables, fruits, soups, sauces, milk, and dairy products.
Okay. Thank you, Dr. Ravi. So you can see that they have also reported the same. We'll see the analysis part, the KMO, and although the KMO value they have taken like 0.5, but again, it should be at least 0.6, what we have seen. If you see the variance, also variance is 40%, which is not a very good variance. Generally, it is said at least 60% of the variance should be, they should be able to explain. And this is, you can see they have given the loading, all the three, this thing they have like vegetables, fruits. These are the items in this case, items in the case of a formative scale. And the three, they have given the name to these principal components. So it got broken into the three principal components. And you can see like they have also taken this this we have seen. This is, I think, output of Jamodi. If you have gone through that article of that Malla, they have for this, they have used R, the Lavan package of R. And if you see that JASP, they have also used the same Lavan. I'll show you. So this, you can see they have taken more than 1.3, which they have said, like they took. And we know that from the parallel analysis, you should take the eigenvalue which lies above this, graph or the simulation. So there are three I should not be using factor now. So there are three principal components, 1, 2, and 3. And this, they have done the statistical analysis. Yes, so they have also done with the R Studio. Can you see R Studio? So this Jamovi, actually in the background, if you see the diagram, this is exactly like Jamovi. Why? Because Jamovi is again, it's generally in R you have to write the commands, but then this Jamovi was invented where it is a click, point and click interface, and you get it, like you don't have to write commands. So that's why, and I have seen that article also. They have also done in R Studio using R package. So this is they have done in R, and then they have done the descriptive analysis, and they have used the binary logistic regression also, because what they did, like after classifying these, if they can do a logistic regression where they can take this as an independent variable, because now they have categorized it. Are you understanding in what cases we can use the principal component analysis? Those of you who understands the linear and logistic regression, if you are taking a dietary pattern taking 13 indicators, how you are going to take that as an independent variable? Because there will be 13, the number of categories are huge. So if you like reduce this into component, then you can take this as an independent variable. And now you will have odds ratio. So probably, I think, who was there yesterday? I am forgetting the name. One girl, she asked regarding how does it reduce, probably it was Bhavna. It reduced the component. So what is the advantage of that? So now can you understand the advantage of reducing the component? If you have got many indicators, even if the clinical symptoms, if there are so many clinical symptoms, you cannot, if you are modeling something, you cannot take that clinical symptoms independently. Then if you like do this dimension reduction, then you can take that clinical some if if there are three components or two components or even four components, then you can take it.
So,
Are you
ma'am, for example, you're trying to say if you are looking at the abdominal system, so you got
yeah
ascites, you got splenomegaly, you got hepatomegaly, and maybe spider nevi in case of alcoholic. I mean, if you're looking at cirrhosis, so you combine under a abdominal system.
Yes, yes.
This is what you
yes
wanted to convey.
Yeah, you club. Why? Because then if you want to see the effect of like I don't know what outcome variable. Let's say if you want to see a severe pancreatitis and a non-severe pancreatitis, or some other disease, severe hepatic cirrhosis versus non, any outcome variable. But the dependent variable, independent variable, there are many clinical parameters. But how you will club those parameters? So for that, either you can do it like arbitrarily based on your experience that these are the abdominal, these are the probably the lung, or but if you want to combine biochemical and clinical, like both two together if you want to do, or biochemical separately and clinical, because I think we received one, Dr. Shamshad was doing analysis of one STS is for ICMR, that UG this thing, and there were like pattern of this, what do you say, in the SLE you get this immunofluorescence pattern. So they had a 25 pattern, but they were very confused like what test to order, if a battery of tests. So they did a PCA and they found out like few were clustering together, few of the immunofluorescence this thing outcome. I don't have that study to show, but again, this dimension reduction, maybe it may not be the sole idea of doing a research, but when you are modeling something and you have got something, any variables like this, so you can reduce the dimension and you can use it. I think we also had a presentation day before yesterday in our PG thesis, where what they have done, they have defined a wealth index. Like Manju was asking now how to take the social demographic status. So in the wealth index, they took like 14, 15 criteria. But all the criteria were not useful, so deleted the few, and using that compartmentalized wealth index, they used it as a independent variable, calculating the model, and that they were like seeing the suboptimal gap between the two pregnancy. Why the gap is like in few cases it is 2 year, 2.5 year, 2.9 year, 4 years. So what are the factors responsible for that suboptimal gap between two babies? And that was a kind of regression they have performed. So are you understanding what I'm trying to tell? I don't know whether I'm making myself clear or not, or I am digressing from the topic. Probably the second, Dr. Shamshad is saying the second one is true. I'm digressing from the topic. So I'm sorry. But you can just see using this principal component, you can compartmentalize these many variables. So coming to this statistical analysis, we have seen this. And now coming to the data per se. I'll show you the question, and this was the article. We'll see the result later on. So this was the problem statement. I think we have shared. Have we shared?
Problem statement नहीं share किया, एक बार read कर दीजिए.
Okay,
Yeah,
I'm reading it. Someone else can read. I think for us.
same.
Any volunteer, can you read this? We'll share it.
Yes, ma'am.
Bhavna. Okay, Bhavna.
The selected
Have you
article
understood?
by
Have you understood now the dimension reduction, which you were
yes,
asking?
ma'am. Yes, ma'am. Yes, ma'am. I got it.
Okay.
So the selected article by Mitran et al. 2024 explores the role of dietary patterns in influencing antenatal care outcomes. In the study, multiple dietary and lifestyle variables are analyzed to assess their collective influence. PCA is particularly relevant in such a context for the following reasons. First is multidimensional data. The datasets likely contains a variety of dietary variables for say intake of fruits, vegetables, protein, fats, etc., some of which may be correlated. PCA helps to reduce this high dimensional data into fewer uncorrelated components while retaining the maximum variance. Second is pattern identification. PCA allows us to identify patterns or clusters of related variables. Example, a component for healthy eating characterized by high intake of fruits and vegetables and low intake of processed foods. Third is dimensionality reduction. By transforming the data into a smaller set of principal components, PCA simplifies the data sets, making it easier to interpret and use for subsequent analysis like regression or clustering. Now, the proposed problem for PCA demonstration. We aim to identify key dietary patterns from hypothetical ANC-related dietary data. Participants will first use PCA to reduce the dimensions of the dataset, example from individual dietary components to a fewer dietary patterns. Second is to interpret the principal components, example healthy diet versus processed diet. Third is to visualize the contribution of variables to each component using loadings and screen plots. Simulated food frequency questionnaire based datasets for PCA with frequency based categories as never zero for never. Okay.
No, you please continue. Dr. Shamshad was telling some other.
Okay. So simulated food frequency questionnaire based data for PCA with frequency based categories as never equals to 0, 1 to 3 times per month equals to 1, and once a week is equals to 2. For 2 to 4 times per week equals to 3, and daily equates to 4.
Thank you, Bhavna. So you can see like they have taken this again on a Likert scale. So by this, we just want to convey any scale. If you are able to convert your items into a Likert form scale, at least 5 point. Why? Because 3-point Likert scale, it is difficult to treat it as a continuous. Then you can perform these factor analysis, whether it is exploratory, confirmatory, or PCA, depending on the nature of your data and the nature of your construct. So now I'll show you. Let's see the data. Thank you, Bhavna. This is the, so I should show with Jasper Jamovi. Okay. Let's see. It takes time in opening. So probably in my thing. Let me close other files now. So in the meantime, till the time it is opening, yes, I will tell the few corrections which I made an error yesterday. So regarding the Shivam's query of reverse scaling the item. So if you can recall, we have shared the reverse scale data also. So reverse scaling is in context of that MSA. Can you recall that yesterday few items were showing less of MSA? That was on the KMA test, that the sample adequacy. So I was going through one reference and they said that if the item is, if you find that KMO test, like value of KMO is coming less than 0.6, then see the original item. And if it is a reverse scale item, when you reverse the scale, means you change the scale, reverse the scale, and then your MSA will improve, because many times it has been seen that reverse scale item, the MSA comes less than 0.6. So Shivam, yes, in EFA and CFA, if you reverse scale it, yes, your KMO will improve. Although we have tested that there is no effect on the loading. Loading is same, and all the analysis, factoring, everything is same except for negative sign, which you will see. But yes, KMO, that it will improve. So if you do that, that is good. Why? Because then again, if you have to sum up the score and if you have to see the difference between male and female and everything, then again you need a total score. So for total score, again, you need to reverse scale your item. If time permits, I'll show you how to reverse scale. You can do it in the Excel or you can do it here also. So that is, I'll explain the data. Jamovi, I hope all of you are familiar with this interface. So this is these are the intake: fruits, vegetables, grain, processed food, legumes. 13 food items are there. I think it's more than 13, it seems.
16.
16, yeah. 16 food items. And analysis, what option I'll go? So if you see this factor, this one, I have used this. So I'll go to this factor and there's an option of principal component. So I'll click this principal component. Again, if you see here, I have not moved the variables, but if you see the method, the extraction which you have seen there in case of this thing, that extraction method is not here. Here it is a rotation and the number of components. They have not used the term extraction. Why? Because we are not extracting the factors. Here the two assumption check, again I said that these two, Bartlett's and KMO, let me move first these variables. So I'll select this fruit, press shift button and select this desert and move the variables here. Here also you can see the two type variable which I can insert is the ordinal or scale variable. I cannot enter a nominal variable here. So this is my structure and here I have to check the assumption. So I'll go and check the assumption first to see the MSA and this minimum sample adequacy, the KMO measure and so if you see the p-value is significant. That means we can go for the principal component analysis. And in principal component, again, it is said that they should be, again, you might ask here if they are correlated with each other, why there is this thing. But again, I said that some amount of correlation will be there, that will not be as strong as you see in case of a factor analysis. And if you see here, the MSA, overall MSA is 0.73. And if you see the item wise, I'm also calling it as item here, item or indicator, whatever you say. So I think all except this, if you see this egg, it is having a less, otherwise all other are like having a MSA more than 0.6. So I can go, these two assumptions are met. Then I can go for this rotation. Rotation here, you can use oblimin also. You can, so oblimin I'll just click. And here the number of components, I will use this parallel analysis. And again, I like yesterday also, there were few participants who were asking like, if they want to take eigenvalue. So I was like, in the same book, I just read that eigenvalue these days, you don't take only the eigenvalue as a number of factor. It should be like either the parallel eigenvalue together or parallel is the best. So although for academic purpose, we have explained that you can take eigenvalue, all the factor of having eigenvalue more than one, but ideally that is not practiced now. So you should use the parallel analysis. And then component loading, by default, it comes as 0.3. And if I just sort it by load size, then all these will be in one this thing. So you can see here it has.
Excuse me, I had two small questions, Ram.
Yes.
In PC also, do we need to reverse code the items, or is there something like reverse coding here also in PCA? Like for dietary data, is there something like reverse coding?
I think it should not be there because here the items are generally asked like this. Negative, we don't ask negative questions here. We ask like, do you take these item like never or 1 to 3 times or once a week? If you have something, but since here the items are distinct, because in VFA, why you take reverse coding or why you form the positive and negative statement? Because there can be agreement bias because all the items are very similar to each other. That's why we say that you should have both the negative worded and the positive worded items. But in case of a PCA, generally all the factors are very distinct to each other. Like if you see the wealth and if you see the occupation, they are entirely, distinct. So there's no chance that they will go on ticking or in that agreement wise. They'll see each item carefully because each item is distinct. So that's why reverse scaling, I don't think it is there in the this thing. In case of a
And ma'am, the sample size requirement is the same, like 10 items per,
yes, yeah, 5 to 10.
10 people per item. Yeah, 5 people. Okay.
5 to 10, they say if you take higher side, then your you can say structure is clear and loading is good.
Okay. Thank you. Thank you.
My pleasure. So you can see here again, there is one like legume. If you see the difference again, yesterday, this thing. Yes, if you see the structure, this thing, component, now it is known as component. It is not a factor. And this is component 1, this is component 2, and this is component 3. So you can give a name like they have given a prudent diet and this thing. So sugar, processed food, spices, and again, this is a created data. Okay, this is the random data. So there can be like this, we have just created taking the reference of that article. It is not a real data. So don't go by the interpretation and why this has grouped together. Just see the concept. Okay. So in this created data or simulated data, you can see like sugar, drink, processed food, whole grain, dessert, fruits, it is coming into one component. Dairy food, seed food, nuts, seeds, red meat, this is coming into one. And the eggs, vegetable. That's why you will see like eggs, vegetable, fish, even vegetable has come here. So you might find it a little weird, but since it is not the actual data, so just think that some other category which you can explain. So this, you can see uniqueness here again. Again, you see that if you, the total variance, now there is something known as the component summary. So if you click the component summary, it tells you the cumulative. So this tells you like component 1 explains 16% of variation in this scale. Component 2 together with component 1 explains 33%, and all the 3 component explains 43% of the variance in the scale. And if you see this, there is a overall, this we have seen. So this is just a scree plot if you want to plot, because yes, scree plot for principal component, again you can plot, and you can see and you can copy paste that. So this is regarding the principal component. The option, it is interface is very much similar to what you have seen in EFA and CFA, except for a few differences. So you can see here it has also identified 3 components, you can see, but third one is lying on this. So that's why you see the factor loading here also. Loading, it is in the upper one, you can see the loading is strong, like 0.78, 0.72, 0.6. Here again, loading is a little less, and component is also, number of items in this third component is less.
Ma'am, can you just go up? Can you please go up, ma'am?
Yeah.
Ma'am, suppose, ma'am, had it been a factual data and if you had the dairy being loaded in all 3 components,
Yes,
so
it
in
will be
that
loaded.
case,
Let me make it 0. Actually, it hides loading. If you make it 0, all the factor gets loaded on all the item will get loaded on all the component. The way we have done the EFA. It is not like, but we hide the loading because we don't consider the loading which is less than 0.3 or 0.4. We want a strong loading. Yes, now you ask the question.
so, ma'am, there could be a possibility of a very high level of, say the uniqueness level would go down considerably for dairy had it been a factual data because everybody consumes dairy products.
Yes, true.
Because the variance would be explained to a very high phenomena, and I mean the communality would be very high, right?
Yeah, true.
Okay.
So this one was regarding the PCA, and then I think I have explained that Shivam's query. Anything else before we go to the breakout room?
Ma'am, I have one doubt.
Yes, Haripriya.
Ma'am, like we had loaded it for factor loading of 0.3. So like initially if we are doing, So
Mhm.
we saw that that item legume was loaded in factor number 2 as well as 3.
Oh, should I make it like 0? Okay. Just a sec.
The first thing, not 0, ma'am. Like initially you had put like 0.3, right? So I
Oh,
guess that legume was loaded in, last one. Was loaded in factor number 2 as well as 3.
yes.
So like then, where should we consider this legume actually? In which of the factors we have to?
Okay. Good question.
Mm.
So there are two things. First, you have to see the strong loading. So strong loading, how do you consider the strong loading? So in this example, I just missed this concept. Thank you, Haripriya. This is known as cross loading. I think I have used this term yesterday. There is something known as cross loading. How do we define the cross loading? If the difference between the two loading is less than 0.2, less than 0.2, then we call it as a cross loading. And in that case, if it is so if you see the difference, it is less than 0.2, isn't it? It is 0.15. Okay. So this item is a cross loaded item. We will call it as a cross loading. And in that case, you have to drop this. You will not take this into either the factor, the component 2 or component 3. Okay. This is a cross loading. If the difference of these two, there can be a scenario where difference between these two will be like more than 0.2, like had it been this one like 0.6, then in that case you will consider this legume under component 3.
Mhm.
Am I making myself clear to all of you?
Yes,
I
ma'am.
think I have used this term cross loading, but I have not demonstrated what is this cross loading. So cross loading is like if a particular item is getting loaded on two of the component, and you see the difference between the two loading. If the difference between the two loading is more than 0.2, then you consider that particular item on a particular component which has got high loading. But if the difference is less than 0.2, then it's better to drop that because it is not clearly getting loaded on any of the component. Right? Am I making myself clear to all of you?
And what if it is exact 0.2? Then also we have to go with the
Up to you. जहाँ suitable होता है.
more than or equal to 0.2.
Generally, yeah, you can take that. Sorry. You can take that, Haripriya. Even if it is like generally we say it more than 0.2. If it is up till 0.2, it is up to you. You can either
Where it is more suitable.
like whether you can then use your like rationale. Like what do you think? Like legume should go into the like when you are giving the name now because you
Yes.
will ultimately give a name to all these like component 1, 2, and 3. So you can write like the loading was exact 2. So because I think that it should be go to 3 because if you see this, I would. Although this is not a true, so then I will not. And what you can do again, you can increase a few sample size also. Many times what happens, like if the sample is less, then also this happens. So there are two ways. Either you can increase, take few more people, and then again check your structure. But even if it is like fixed to 0.2, then you can decide. If you want to keep it, then you can keep it wherever you think. If you don't want to keep it, then you can drop. Then nobody will say why you have dropped or why you have kept.
Okay, ma'am. Thank you.
Okay, my pleasure. So yes, Anand, are you there?
Anand is there.
No, I can't.
No, Anand is there.
Okay.
Anand,
Anand, can you hear us? Can you hear me?
Yes, ma'am.
Okay, so will you please open the break?